Good morning, all of you. I am Kiran Pachlasia, Assistant Professor at Sagar Institute of Research and Technology, Bhopal, the SAGE Group. Yes, today we are going to discuss on deadlocks in operating system. In previously, we have already discussed on how operating system manage. So today we are going to discuss on deadlocks. So what are the deadlocks, when it is happened, and why it is necessary to learn about deadlock. So, two basic things before we are going to learn deadlock, we are going to know about what are the processes. We already discussed in first video of operating system. Please go through that. Here, I am going to discuss only one or two lines about process. A process is a program which we are execute. The execution of a process must progress in sequential fashion, first of all. Second point, when we write any program or any text file in our computer, when we are going to execute that program becomes process. So basically, a program is a process. When it becomes process, the time of execution. Second thing is resources. Resources are of many types: hardware resources, network resources. Hardware resources are DMA, input output port, IRQ. These are hardware resources. And some hardware resources, like we already seen, printer. Okay, network resources, cluster, network server farm. These are the resources. So now we are ready for learning about deadlocks. So what are deadlocks? Deadlocks is a situation where a set of processes are blocked. Why they are blocked? Because they are waiting for resources holding with another resources. Okay, understanding? When a single process hold up resource and waiting for another resource, so this process cause deadlock. Here, this is a example. Process 1 are assigned resource 1 and waiting for resource 2. Process 2 assigned resource 2 and waiting for resource 1. This condition calls deadlock. Every process needs some resources for execution. The process requests some resource. OS grant resource if it is available. Not every time process get resource. Number third point, the process use that resource and release that resource after completion. Why deadlock is arise? Deadlock is arise if the following four conditions held simultaneously. Means these four conditions are necessary to have resources in our OS. Number first, mutual exclusion. What is mutual exclusion? Let us discuss in next slide. Hold and wait, no preemption, and circular wait. Number one, mutual exclusion. There should be a resource that can only be held by one process at a time. You can see in this diagram, there is a single instant of resource 1 and it is held by a process. Means in our system, there is only one resource available, and that is held by a process that can be released by a process on that condition. What is that condition? That condition is mutual exclusion. Number second condition, hold and wait. When a process hold multiple resources, as you see here, and then requesting for some other resource. Okay, this condition is known as hold and wait. Number third, no preemption. No preemption condition means a resource cannot be preempted from a process. Okay, a process can only release a resource voluntarily. Look here, in the process 1 have already resource 2 and requesting for resource 1, and resource 1 is allocated with process 2. This condition is known as non-preemption condition. The last condition is circular wait. The resources are in the form of, they are forming a form of circle. Look here in the diagram, process 1 is waiting for resource 1 and resource 1 is held by process 2. Similarly, process 2 have resource 2 requesting for resource 2 and having resource 1. So see, process 1 waiting for resource 1 and having resource 2, and process 2 having resource 1 and waiting for resource 2. This condition is called circular wait. So why this if these conditions are arise in our OS, then what is the techniques to handle this condition so that it can't cause deadlocks? So there is some strategies to handling deadlocks. These are deadlock ignorance, deadlock prevention, deadlock avoidance, and deadlock detection and recovery. So what do you mean by deadlock ignorance? So if deadlock is very rare condition, then let it be happen and we will reboot our system. This is approach that both Windows and Unix we take. We use the ostrich algorithm for deadlock ignorance. Deadlock ignorance performance is better than about 2 method, but the correctness of data. Number second, deadlock prevention. In deadlock prevention, the system will make sure about mentioned 4 condition will not arise. First of all, which 4 condition? Mutual exclusion, non-preemption, hold and wait, and circular wait. These techniques are very costly, so we use this in case where our priority is making a system deadlock free. So what are the 4 ways? The 4 ways are elimination of mutual exclusion, number 1. Number 2, solve the hold and wait condition. Number 3, allow preemption. And number 4, circular wait solution. These are the 4 conditions where we can make sure that there can't be a deadlock in our system. Next is deadlock avoidance. By using this strategy of avoidance, we have to make an assumption. Why? We need to ensure that all information about resources that the process will need is known before the execution of process. So on this, we use Banker's algorithm. Discastra algorithm are used for this deadlock avoidance. We will discuss later, we will discuss separately on these algorithms which are used for deadlock avoidance. Next is deadlock detection and recovery. If deadlock prevention or avoidance is not applicable to the software, then we can handle this by deadlock detection. How we can handle? There are 2 way. In first phase, we examine the state of process and check whether there is a deadlock or not in the system. If deadlock is there in the system, then we apply algorithm to recovery for the deadlock. In deadlock detection and recovery, we get correctness of data, but performance decrease because we measure that. So in later on video, we will separately discuss on Banker's algorithm first, then we will discuss on Discastra algorithm. Thank you so much for watching. Stay tuned. Keep learning.